Hello everyone, welcome to today's class. Today we shall learn about structure of atom. We all know that children, in the previous class we have studied about atoms and molecules, in which we have understood matter is made up of atoms and molecules, and an atom is the smallest particle of matter. And we know that Dalton discovered atom, and according to him the atoms of small same elements are similar, and the atoms of different elements are differ in their size and mass. According to Dalton, he said that atom is the lastest or the finest particle which cannot be further divided, and he said that atom is undivisible. But during the time of 18th and 19th century, scientists like J.J. Thomson, Goldstein, Rutherford, James Chadwick, Niels Bohr, and many carried out many research, and finally they wanted to know that what actually atoms contain, what is there inside an atom, whether it is divided or is it the finest or final particle of the matter. And they established that atom is not as simple as predicted by Dalton. And finally they showed that inside an atom there are some other particles or subatomic particles called electrons, protons, and neutrons. So in this chapter you are going to learn the discovery of subatomic particles like protons, neutrons, and electrons, children. First is electrons. The first subatomic particle that was discovered is electrons, children. So electrons are nothing but the fundamental particle present in an atom which carries negative charge and which has negligible mass. Negligible mass is we cannot weigh it. That means it's very lightweight. You know that atom is the very smallest particle, and inside an atom electron is present means how small it is. It is too very small. It is beyond our imagination, and it was discovered by J.J. Thomson in the year 1897. So it is denoted by small e, by charge, negative charge, and its charge can be measured in coulombs, that is 1.6 into 10 to the power of minus 9 coulomb, and mass of an electron is 9.1 into 10 to the power of minus 31 kg, which is too small. So this picture is of J.J. Thomson, and he is the man who first discovered electron, and he finally says that Dalton is wrong, that atom is not the only the last what Dalton said, that atom is undivisible, and finally he proved that Dalton is wrong, that even atom contains other particle, that is electrons. So let us learn the discovery of electrons. How J.J. Thomson discovered electrons. So this J.J. Thomson discovered electrons in an experiment which he was performed in a discharge tube. So his discharge tube, this tube is called as discharge tube, and this discharge tube is a long cylindrical tube which is made by hard glass, and it is sealed at both the sides. It is sealed at both the sides of the ends, and it's fitted with metal metal rod, which are called as electrodes. You can see in the picture. So the electrode which is connected at both the ends, you can see there. The electrode which is connected to the negative terminal of the battery is called cathode. You can see the left hand side, children. the electrode which is connected to the negative terminal, which is called as cathode, and the electrode which is connected to the positive terminal is called as anode. So two electrodes has been connected. Electrodes are nothing but metal rods, and two electrodes are connected to a source of high voltage. For this, an induction is used here which has high voltage. So high voltage generator is there, and the tube is connected to a vacuum pump. You can see near the anode a vacuum pump is fitted to the discharge tube. Why it is fitted? To reduce the pressure inside the tube. It could be any extent. So we can reduce the air pressure inside the tube to any extent. For that purpose, vacuum pump is fitted here. So the discharge tube was filled with air, normal air. So what happens after when he flow, or when he uh, passed high voltage of electricity? What happened? This is how he fitted his discharge tube. What happens? Let us see the observations. A current of high voltage, say 10,000 volts, was passed through the discharge tube under normal atmospheric pressure. Normal atmospheric pressure means when you are in at the normal air pressure, he passed the electricity, and it was voltage of high voltage, that is 10,000 volts. So no electricity could flow through air. Why? Why the no electricity couldn't flow there? Because we all know that air is a very poor conductor of electricity, which do not conduct electricity. And then using the vacuum pump, he reduced slowly the pressure inside the discharge tube. How much he reduced? He used the vacuum pump and he reduced the pressure inside the discharge tube about 1 mm of mercury. So reducing the pressure could be measured by 1 mm of mercury, mm of mercuries. And on passing electricity through discharge tube, when he reduced to 1 mm, again he passed the electricity in the discharge tube. What happens? He saw that electricity started flowing through the tube. As a result, light was emitted in the tube. He observed that light was emitting in the tube when he reduced the pressure inside the discharge tube about 1 mm. Then the emission of light was stopped. Again he started reducing the air pressure inside the discharge tube for about only 0.001 mm. After 1 mm he reduced again for 0.1001 mm. When he reduced it to again 0.001 mm of mercury, the emission of light was stopped. But the walls of the discharge tube opposite to the cathode, opposite to cathode means it is anode, he observed that a greenish light was glowing near the anode, and he called it as fluorescence. On further investigations, he did many investigations and many experiments using the discharge tube by changing the electrodes with different metals like copper, iron, and also he changed the gas which is present inside the discharge tube, and he did many experiments. After doing many investigation, it was found that fluorescence, that means the green color light which he observed, is due to the bombardment of the walls of the tube by the rays emitted from the cathode. That means he said that he finally concluded that the fluorescence, that means the green color light, what he observed the green color light, what he observed in the anode, that means the right hand side, that is because of bombardment of walls. Bombardment means hitting, very forcefully hitting of the rays that are emitted from the cathode. So the rays which are coming from the cathode, they are hitting the anode forcefully on the walls, and then he called it as cathode rays. So the rays which are emitted from the cathode, they are called as cathode rays, and these cathode rays are finally hitting to the anode. This is what he concluded. He said that the greenish glow or the fluorescence, what you can observe here, the greenish light fluorescence, which is called as fluorescence, this is because of emission of, or the rays which are coming from the cathode, they are directly bombarding or hitting forcefully on the anode side, which creating greenish glow, and he called as fluorescence, and the rays which are coming from the cathode are called as cathode rays. Let us learn the characteristics of these cathode rays. From this, what he concluded that cathode rays are emitted either from the metal. So the metal means electrode which is connected there in the cathode region. So these cathode rays could be emitted from the metal which is fitted at the cathode, or from the gas which is enclosed in the discharge tube. He said that it could be the gas inside the discharge tube or the electrode or the metal which is connected to the cathode. They are emitting cathode rays, and cathode rays always travels in the straight line. He says that all cathode rays always travels in the straight line, and cathode rays consist of negatively charged particles known as electrons, and this is how we could discover that the cathode rays, by discovering electrons, he discovered cathode rays, that cathode rays are nothing but negatively charged particles called electrons. So when cathode rays made to strike on a metal, or when these cathode rays are made to strike on any metals, they will get heated. And when cathode rays made to strike on surface of certain metals like tungsten, copper, molybdenum, etc., they produces X-rays. So this is how X-rays are produced, children. When the cathode rays, you know that cathode rays are nothing but the negatively charged electrons. They contain negatively charged electrons. When these cathode rays are made to strike or hit on the surface of metals like tungsten, copper, molybdenum, etc., they produces X-rays. One more characteristic is cathode rays can be deflected by electric and magnetic fields. So if you bring the electric field near the cathode rays, it could be deflected, or if you bring the magnetic field near the cathode rays, it could be deflected. So these are the characteristics of cathode rays, and this is how J.J. Thomson discovered electrons in an atom. So I hope you have understood this, how electrons have been discovered, children. The next class we are going to learn another subatomic particle, that is protons, and how it is discovered. Thank you, students.